Okay, so let's do another example for indented contour. So second example. So here we will just use the lemma. I will try to make it as short as possible so that you can just do the same on the test and the final, on the quizzes in the final. So evaluate the principal value of 2 cosine, what is it, 2 pi x and 6. So this is from your book. That's why the numbers are a little bit funny. So x minus 1 and x squared plus 1. Okay, so again, don't jump the gun and try to do a semicircle. So first ask, what are the poles? Okay, well, they are x equal 1 and then plus minus I. Okay, so 1 falls on the axis, on the real axis. Okay, so we have to do indented contour. There's no way around it. You have to indent to avoid the pole. Okay, so that's a given. All right, fine. Let's start. So, yeah, let's first do the residue theorem since we found the poles. So we have residue um, of what? Of So whenever you see a trigonometric, just put exponentials. So 2 pi z and z minus 1, z squared plus 1, and the other integral as well, plus 6 ei 2 pi z dz. Okay, so you have these two poles, and the contour is like this, so it skips 1, right? So 1 is over here, and it skips it. It doesn't skip 0, it skips 1. That's the problematic guy. There is no z here, it's z minus 1. If it was z minus 2, we will skip 2. Okay, so let's do residue theorem for this guy. We have z minus I, z plus I. You can straight away see that only one guy matters, I. So we have 2 pi I, and it's order 1. So residue of this function at I order 1. Okay, so what is it? So yeah, you have, let me write it. So z minus I, e to the I z, z minus 1, z squared plus 1, and right, so we have 2 pi I, with 2 pi, uh, minus 2 pi, and then I have, what is it, I minus 1, 2i, and if you simplify that, you get e to the minus 2 pi over 4 and I minus 1. Okay, um, right, if you only do, I should mention this, so let's just do this guy for, because it's the same. So I'm just doing this guy first, just a single integral. Okay, so that's that. So we found the residue. Second by we do the Jordan lemma. By JL, we set P to be 1, Q to be Z minus 1, Z squared plus 1. So indeed, this integral goes to 0. So that guy is out. And finally, we study the C epsilon integral, which, okay, in our case, it goes this way, right to left, right? So we go like this, and then right to left. Okay, so EIZ, Z minus 1. Okay, and we take the limit as epsilon goes to 0, here as R goes to infinity. Okay, so by the lemma, you can just use the lemma. I should have a name, if you like, indented contour lemma. Okay, if you like. All right, so we have this lemma that says that this guy is equal to the minus, because you have to switch. So let me write it. It has to be counterclockwise. Then, yeah, so by the lemma you get minus pi I residue of the function at 1. It's order 1. Okay, so let me write this for you. So this is z minus 1 eiz z minus 1 z squared plus 1 evaluated at z equal 1. So 1 second. So this is I pi of what? E to the 2 pi and then divided by 2. Okay, so if you do the computations, yeah, like it's 1 plus 1. So you get 2 and then, okay, yeah, and this is 2 pi. All right, so now let's put everything together. And that's it. So we did it in 4 minutes. So let's put everything together. So we have, again, you don't quite have to do this. You can just write the final answer. Okay, so we computed EI 2 pi Z. This guy was equal to this. So 2 pi I minus 1. So 2 pi I e to the minus 2 pi over 4 and then I minus 1. Okay, so that's on the left by residue. And then if we take all the limits, we have our principal value, our desired. So it's e to the 2 pi x minus 1 dx. And then the thing we just found, which was, what was it? 1 second. So over here. So we have minus pi I e to the I 2 pi over 2. Okay, good. Okay. Of course, you can simplify this. E to the I 2 pi is this 1. So I might as well just write 1. So we have pi I over 2. Okay. So let me move things around. We have PV of this e to the I 2 pi x. Okay. So what is it? Yeah, 2 pi I 4I minus 1 and then plus pi over 2. All right. Now what? Okay, so you can simplify this. Um, so we need to write this into the real part minus 2 pi e to the minus 2 pi over 4 plus I pi over 2 and then minus 2 pi e minus 2 pi over 4. So why am I doing this? Because our guy was PV of 2 times cosine 2 pi x and 6 times sine 2 pi x. Okay, and you split this guy, so it's the real part, so 2 times the real part of PV EIX 2 pi and 6 times the imaginary part PV EIX 2 pi dx. Okay, so what am I trying to say? Um, so the first guy is the real part from above, which was this. Well, the two cancel out. So, 1 second. Okay. So, um, right. So it's 2 times minus 2 pi e 2 pi 4. That's the real part. And then 6 times the imaginary, which was pi over 2 minus same guy, 2 pi over 4. Okay, and I guess, yeah, let's try to simplify. So the 4 cancel out. So you have minus pi e to the minus 2 pi. And yeah, there's not much we can do here. So we have 6, so 3 pi, and then 3 pi e minus 2 pi. Yeah, I guess we can group these two. So 4. So yeah, this. Okay, good. Thank you.